this section we ask, what governs whether a shelter will be able to support its own weight? It's really the same question as, why do elephants have disproportionately thicker legs than ants?
Wow.
Let's start by thinking about us, humans, standing up, supporting our own weight. Our bones have to be thick enough and strong enough to support our weight. If our bones were made of something less strong, like plastic or polystyrene, then we collapse under our own weight because these materials are not strong enough to support us. Assume now that we are supported by a strong material, bone. What governs how thick our bones have to be to support our weight? Well, our weight is our mass times gravity. Our mass is how much stuff we're made of, intrinsic to us, it doesn't depend on where we are. But gravity, little g, is a property of the planet we're standing on. For example, on the moon, gravity is only 16% of the size that it is on Earth, so our bones don't need to be as strong to support us because our weight is much less there. In contrast, the gravity on the planet Jupiter is 2.5 times bigger than it is on Earth, so our bones would need to be much stronger to support us because our weight would be much bigger there. Assume now that we are stuck on Earth with Earth's gravity and we can't change the material of our bones, but we can change how thick our bones are. How thick should our bones be? This now depends on our mass. If we are bigger, then our bones will have to be thicker to support our weight. That stands to reason. However, if we get bigger, our bones get thicker by a greater amount, meaning that elephants have disproportionately thicker bones to ants. What's the reason for this disproportional increase in thickness as animal size increases? Basically, it's because the crushing force depends on our mass, which depends on our volume. However, it's experienced by our bones as pressing down over an area, a pressure. Let's consider what would happen if we doubled our size. Our volume would double, meaning our mass would double, meaning our weight would double, meaning the force our bones would have to withstand would double, meaning the cross-sectional area that our bones would need to have to withstand the same pressure would double. In summary, if you double your size, to keep the pressure on your bones the same, their cross-sectional area has to double too. Now here's the confusing bit. Is this, or is this not, a proportional increase in area? Proportional means that if the volume doubles, the area doubles, right? Wrong. Perhaps counterintuitively, doubling the volume under a proportional increase means the area gets multiplied by 1.59 and the length by 1.26. Going in the other direction, if everything changes proportionally and we double the length, then the area goes up by 4 and the volume by 8. So, to conclude, because the material bone can only withstand a certain pressure, when we increase our size, we must increase our bone thickness by the same amount. And that is why bigger animals have thicker legs in comparison to their body size than smaller animals. Extending this back to our shelter, to stop it buckling under its own weight, we could give it more, thicker or stronger legs, or we could reduce the weight it has to support. A lighter roof perhaps. Bigger animals need comparatively thicker legs because their weight, which goes like L cubed, is felt over an area which goes like L squared.